So the following example, we want to find an equation of a straight line that having the slope of a quarter that is tangent to the curve f of x equals the square root of x. So basically what we're trying to do is we're trying to find where on this function f of x, what value of x has a slope of a quarter. Okay, so we want to look at the derivative function. So let's find f prime of x. Once we find the derivative function, we could set that derivative function equal to what we want the slope to be. So we would then look at when is f prime of x equal to a quarter. Well, once we figure out what that is, what x value, all we need is, we know what the slope is of our line. We need to know what that point is on that line. So find the point on f of x, where f prime of x equals a quarter. And then you're going to find the equation of the line. Okay, so let's look at the derivative. I know f prime of x is equal to the limit as h approaches 0 of f of x plus h. So that would be the square root of x plus h minus f of x, so minus square root of x all over h. This is in the form where we would get, again, an indeterminate, 0 over 0. So we want to manipulate it. When we have radicals, that's where we use the trick where we're multiplying by the conjugate. So that fancy one, so the square root of x plus h plus the square root of x. Reason why we did this is multiplying by the conjugate gives us the difference of squares. We're going to get rid of those radicals. And so when we just do this, this is the same thing as a squared minus b squared. So squaring this first piece, square root of x plus h, just gives me x plus h. Minus, and then squaring the square root of x just gives us x. All over h times the square root of x plus h plus x, square root of x. Notice our x's cancel in the numerator. And then notice that we would just have an h left in our numerator. And so we can cancel those h's out because that's all that's left. And so in our numerator, we'd be left with just 1 all over the square root of x plus h plus the square root of x. So now we can do our direct substitution. And when we plug in 0 wherever we see an h, notice that we get back 1 in the numerator all over the square root of x plus the square root of x. Well, those are like terms in that denominator. And square root of x plus square root of x is 2 square roots of x. So we just found out what the derivative was of our function f of x, which is 1 over 2 square roots of x. The problem wanted to know, though, when was this equal to a quarter? So we want to know when is 1 over 2 square roots of x equal to a quarter. So a couple ways that we could approach solving for x here. I notice it's a fraction equal a fraction. So we can use that cross product, which is the same thing as thinking about, let's just cancel our fractions by multiplying both sides by our LCD. Our LCD in our case of those denominators is 4 square roots of x. We multiply something on one side of the equation, we got to also do it to the other side. So notice that on the left-hand side, 4 square roots of x all times 1 over 2 square roots of x. Things cancel and we're just left with 2. Square roots of x cancel and 2 goes into 4 twice. And then on the right-hand side, this is equal to, notice our 4's cancel here, and we're just left with the square root of x. Okay, so now I look at what type of equation I have. I notice it's an equation with radicals. So recall, when you're solving equations with radicals, you have to isolate a radical on one side, already done. And then we can raise both sides of our equation by the index. Like this case, it's the square root, so I'm going to square both sides. So 2 squared is 4 equals the square root of x squared is x. We got to be careful. Recall, if you raise both sides of an equation by an even power, which we did, we might get a solution or an extraneous solution that doesn't work. So we need to check this. So let's go back up here. Where was our equation? So we need to check, is this true? Is a quarter, is this equal to 1 over 2 square root of, plugging in 4 where we see an x? And I see that that is true. Square root of 4 is 2, and 2 times 2 is 4. Okay, so we found that x value that gives us a slope of 1/4. So we just found that f prime of 4 equals a quarter. So we want that point when x equals 4. So f of 4, well, plugging that into my function f of x, this is equal to the square root of 4, which is 2. So our point is going to be 4, 2. Our slope of that line, we were told at the beginning, they wanted it to equal a quarter. And so now we can go through and find that equation of a tangent line. So I'm going to use y equals mx plus b, plug in what we know for our point and our slope and solve for b, and then we have that equation. So plugging in what we know, we have our y value is 2 equals our slope, which is a quarter, times x, which in this case is 4, plus b. So we have 2 is equal to a quarter times 4 is 1 plus b. Let's subtract 1 on both sides, and so we get b is 1. So knowing that our slope is a quarter, our y-intercept b is 1, plugging those values back into the slope-intercept form, our equation of the line is going to be y equals the slope a quarter times x plus 1. Okay, so just to recap what we just did, we were given a function, we were asked to find a straight line with a slope of a quarter that fell on that function. And so we found the derivative of that function. We set it equal to what the slope of that line we wanted, which was a quarter. We figured out what that point was on our function, and then we found that equation of that tangent line. So questions on that?